so from the top, this is Friday, January 24th. There we go. Okay, rational zero theorem. Again, theorems, you have to know the stuff, you have to understand the stuff in the box on the right, but you don't really need to know its name. You're not going to need it in a proof. It's not going to be matching or give a definition. You just have to understand what's over there. So let's see if we can read through this and make sense of what that's saying. Let f of x be, and then look at all these letters and numbers, a sub n, x to the n. A sub n minus 1, x to the n minus 1. Okay, so the x's are going down in power, and there's a bunch of x's. So that looks like a polynomial. In fact, it says represent a polynomial. So this, all of that, is just like a generic polynomial. We don't know the specific powers. We don't know the coefficients. But that's like the easiest way we can write a polynomial, a generic polynomial, with integral coefficients. So all those a's are integers. If p over q, is a rational number in simplest form and is a zero of this polynomial, then p is a factor of a0, that would be the last one. Q is a factor of an, that's the first one. All right, this is a very complicated way of saying that our possible rational zeros are plus or minus factors of the last coefficient over factors of the first coefficient. Possible rational zeros, factors of last over factors of first. Meaning, if you're just trying to guess what the zeros are, rather than guessing at random, you guess from this pool of possibilities. Let's work an example, and maybe it'll make more sense. So find all the zeros of 6x to the fourth minus x cubed plus 4x squared minus x minus 2. Since f of x has degree, what's the degree of this polynomial? The function has how many zeros? 4. But I don't know what they are, and I can't factor that because that's too big. So I'm kind of stuck. So someone figured out that, well, if we just want to guess them, our guesses are always going to be plus or minus factors of the last term over factors of the first term. So what are the factors of 2? What two numbers could I multiply to get 2? 1 and 2. So my factors of 2 are just 1 and 2. Get a few more options on factors of first. Factors of 6. I have a couple ways to write these. It's up to you, but some people think of them in pairs, like 1 times 6 and 2 times 3, and so they'll write 1, 6, 2, 3. Other people, it's like, well, that's kind of annoying. I want them to be in order. It doesn't matter. Like, your brain probably thinks 1, 6, and 2 and 3. That's probably how you first think of the factors, because they're pairs. If you rearrange them on the fly to put them in order, that's okay. All right. Well, that's not a sufficient answer, because that's not really a list of all the possible rational roots. That's just like factors of last over factors of first. So we need to write them all out. So let's take the 1s over all of the denominators. So we'll start with 1. So 1 over 1, that'd just be 1. 1 over 6, 1 over 2, 1 over 3. And then we'll do the same thing with the 2. Be careful though. I don't want to repeat factors. So if I've already got it written down, I don't need to write it again. 2 over 1, so that's 2. 2 over 6, What's 2 over 6 the same thing as? 1/3. So I don't need to write 2 over 6. 2 over 2, that's the same thing as 1. And then 2 over 3. 2/3. All right, so how many possible rational roots do I have? That's what I expected everybody to say.
12.
Why 12? The plus or minus. So 12 possible answers, or possible roots. So it's guaranteed that not all of those will work. How do I know that not all of those are roots? Because there's only 4. And I just listed 12. So that's why we say they're possible, because it wouldn't even work that all of them would work. So maybe up to 4 of them work. Maybe not even that, because there are irrational roots, weird square roots, or imaginaries. So at most 4 of those work. Definitely not all 12. Again, that's sort of my list of guesses. It's another way to phrase that. This kind of comes in the land before calculators. If you didn't know how to find a 0, well, you got to guess some things, and rather than guessing at random, at least guess some things that might possibly work. Speaking of guessing, test some possible roots. So let's just see if we stumble into one that works. Is there one that you'd like to try? One's an easy one to try. When I say try, how am I going to see if it works or not? Okay, so I could plug it in. What's another way to plug it in? A different, new way we learned? Synthetic division. So let's try x equals 1. Who knows? We are really just guessing at this point. I mean, I have the answer, so I know, but we're just guessing. 6, -1, 4, -1, -2. And what am I looking for? Like, how will I know if x equals 1 works? If the remainder is 0. If the remainder is 0, then that means x equals 1 is a root, x minus 1 is a factor. Let's see what happens here. Bring down the 6, multiply, add, multiply, add, multiply, add, multiply, add. So what did I learn about x equals 1? Not a root. Okay. Well, let's pause this thing, because how many more guesses are there? 11. Do you really want to do this 11 more times? So let's change this to test one possible root. Then we're going to insert some words here. Use the calculator to factor completely. So we're going to learn how to use the calculator to help us factor. Okay, so factors and roots go together. So I can't get the factors straight from the calculator, but I can definitely get roots from a calculator. So with the calculator, let's put in y1 equals our equation. And if you're borrowing one of mine, it should work because we batteried them all up during first period. Oh, your batteries are low. That's okay. So y equals, and again, I'm walking through the 83s. If you're comfortable with the inspires, that's fine, but I'm not. So when in doubt, use an 83. 6x to the 4th. By the way, the x button on the 83 is toward the top left right there. You just x, t, theta, and n. But the calculator knows which one of those you want because you're trying to put in a function, so it uses the x button. Minus x cubed plus 4x squared minus x minus 2. And then let's graph that thing. Looking at the graph, so I want the roots. The roots are there and there, right? Now, pointing at them and saying there and there doesn't help me find them, what they are, but conceptually, it's where it crosses the x-axis. You're on an Inspire. Ask an Inspire friend. I can't help with the Inspires. Okay, so we're going to find these zeros. One way that would be nice to find them is with a table. So we'd be looking for y equals 0. The trouble is this one doesn't have any y equals zeros. So none of the integers are going to work. Which, if I was just guessing, that means I could rule out all my integers. 1 and 2, plus and minus 1 and 2 aren't going to work because they don't make 0. So table is nice because it's quick and easy. It just only works for integers, unless you really know how to play with the table. So the second way is, and this is where we'll split paths depending on if you've got an 83 or an Inspire, but with an 83, you'll do second calc and then 0. So second calc, and I'm looking for 0, so let's pick 0. Then if you make it that far, it walks you through the rest of the way. So you don't have to memorize everything. You just memorize second calc. You know you want a 0. Left bound. So your calculator is going to find the 0 for you, but you have to tell it where to look. So left bound means get to the left of the 0. Let's find the 0 on the left first. So get to the left of the 0, anywhere to the left of the 0, and press enter. Find it, Micah. After you press enter, it says right bound. Now it wants to know, okay, so how far right do I go before I stop looking? So just get to the right of the 0. Be careful though, don't come way over here, because now you got 2 zeros in the window, and we only want to find the 1 0. So press enter again. And you can maybe barely see it, but there's 2 arrows at the top. That's showing you that the calculator is going to look in between those 2 for the 0. For guess, you can try to get close if you want, but you're saving the calculator like milliseconds. So it takes you longer to find, for you to get there closer than to let the calculator just do its work. So just press enter for guess. And there we go. There's a 0 at x equals negative 0.5. Also known as negative 1/2. Okay, well, there's another 0 there. Almost like we picked this problem so that I could find one and you could find one. So why don't you see if you can find that other 0. So second calc 0 and then follow the prompts. Okay, it looks like everybody found that second 0. Second calc 0. Left of the 0. Again, as long as you're left of the 0 you're looking for. Right of the 0. And then enter. And most of you figured out that 0.66666667 was 2/3. Okay, so I've got 2 of the zeros. We know there's 4 zeros, but something weird's going on here. There's 4 total zeros. We found 2 of them. That means there's 2 more. Any idea what's going on? Where are the other 2 zeros? Why can't I see them? They might be imaginary. They also might be repeated. We don't know that yet. So you don't see all the zeros. Like, you won't see them if they're repeated, and you definitely won't see them if they're imaginary. So I've got 2, and somehow I've got to find the other 2. Well, let's synthetic divide with the ones we have. So I'm going to synthetic divide with negative 1/2. And the good news about synthetic dividing with a known root is what? What should happen if x equals negative 1/2 is a root? Then what should I get over here at the end?
0.
I should get a remainder of 0. So you can, I warned you previous days to be careful when you're synthetic dividing. But if you know the answer is 0, then I'm not going to say don't be careful. But you can cruise through a little faster, knowing that if you get 0 at the end, you got it right. If you didn't get 0 at the end, then you better go back and find the mistake. Okay, here's now, on one hand, it's like, well, why did we do that? We already knew negative 1/2 worked. So we weren't really doing this to check negative 1/2. We knew that worked. The reason we did that is we went from a x to the 4th polynomial, and we divide by 1 power. Now we're down to an x cubed polynomial. And here's the fun thing. We can use the other root on the reduced coefficients. So every 0 we find knocks us down a power. So we started x to the 4th, we found 1, now we're down to x cubed. We found another, this should take us down to x squared. And we should get 0 again for our answer. Okay, so we confirmed that 2/3 worked, but that's not really why we did that. The reason we did that is now we've got 6x squared plus 6 as a factor. Let's see here. Let's find the 6 is a little bit weird. You can factor it out, or you could just move it over. So x squared equals negative 1. So x equals plus or minus I. How many zeros do we have now? We got our 4 zeros. So actually we're kind of out of order here, but we can turn our zeros into factors. So if negative 1/2 is a factor, or excuse me, if negative 1/2 is a 0, then 2x plus 1 is the factor. And if 2/3 is a 0, then 3x minus 2 is a factor. And you can multiply it out if you need. Maybe you can just figure it out. What factor would lead to x equals plus or minus 1? Well, then multiply it out and let's see. X plus I times x minus I. Wait, I said that wrong, didn't I? What factor would lead to plus or minus I? X squared plus 1. Now we've got it factored. If we wanted to check that that factoring was correct, how could we do that? Do you know? Yeah, you could multiply it all out. It'd be kind of annoying. But if you absolutely wanted to make sure, you're trying to make 100 on the test, you got a few extra minutes, I can multiply it all out, and you should get back to what we started with. Now, there's kind of I think we've done this before, kind of a shortcut way to maybe not multiply it all out, but sort of halfway multiply it out. Like multiply all the first terms. 2x times 3x times x squared. That would be 6x to the 4th. That checks out. And then multiply all the last terms. 1 times negative 2 times 1 would be negative 2. So I didn't check the whole thing, but at least the first and last term check out. So it's like a medium check. Not perfect, but it's really quick and really easy. So I feel pretty good about that for my factors. For my roots, we already found these because we're working this problem kind of out of order because we're using the calculator to find the factors and then using those factors to find, using the calculator to find the roots to factors, but we already have the roots. Negative 1/2, 2/3, and plus or minus I. So this lesson is kind of weird because we used to do this lesson like long ago, before you were born long ago, without a calculator at all. And so it's back to, well, just keep guessing until you find one. Actually, you probably need to find 2. And so you have to go through all these guesses. And if you're lucky, maybe you guessed negative 1/2 and 2/3 right away. But you probably checked 1 and negative 1 and 2 and negative 2. And so you could have guessed a lot of wrong things and spun your wheels. Later, we're like, you know what? Let's just cheat a little bit and use the calculator to find the roots, and then kind of combine our calculator knowledge with our work by hand knowledge to come up with the factors and the roots. Jake?
Will a root at the end of this always be the simplified version of plus 6?
We'll say that again. You'll always get this when you divide by those 2 roots.
And will that become your factor later?
Yes.
If you were to simplify all this?
Yes. The 6 thing is a little weird. It kind of is related to, if we wrote this as x plus 1/2 and x minus 2/3. If we took that 6 out of there, and I guess put 3 of it onto this one and 2 of it onto this one, then we would get our integers. Usually we don't worry about that. We just know how to make the integers work, and we take the 6 off and don't worry about it. Okay, today's assignment, we'll do some of it together, because I've kind of only done one example at this point. Today's assignment is 13 through 19 odd. 13 is pretty easy because all the factors you can find on the calculator, and so there's really not even, it says show work algebraically, but with a calculator, all you're going to find is the 3 zeros, and then turn those zeros into factors, and you're done. So 13 is pretty easy. There's really not much work to show. Let's do 15 together, though. Factor completely using integers, but we're going to kind of cheat to find our factors. So back to the y equals, clear that one out and put the new one in. X cubed minus x squared plus 4x minus 30. How many zeros is this thing going to have? How many zeros are we going to get? 3. We should get 3. Doesn't mean they're all on the calculator, but there should be 3. Go to the graph. How many real zeros do you see? 1. But that's okay. We can find the 1. Oh, if I remember right, this one you can... Calculator will get you there, but remember, it's sometimes good to check the table because it takes no time at all, and if there's one there, you find it right away. So what do we find as one of our zeros? Yeah, x equals 3 from the table. I don't even have to do the second calc 0. Now, if you do it, still work. Left bound, right bound, guess. Hey, x equals 3. What do you know? That's the only answer I have so far. So let's synthetic divide with the 3. because what will happen if I synthetic divide a cubic? What will I be down to? A squared. And you can always solve the squared, right? Because you can always use the quadratic formula. So as long as you find enough zeros to get it down to x squared, then you're kind of home free after that. So synthetic dividing by 3, or with 3. Not really because we're checking to see if 3 works. We know 3 is going to work. We want to know what the reduced polynomial is. Yay, we get 0 for an answer, but we expected that. Reduced coefficients, x squared plus 2x plus 10. I'm looking back. Determine all zeros and factor completely. So I've got to do both. Give the factors and give the zeros. So I've got one of the zeros, which means I've got one of the factors. Got the other factor, it won't factor further. Right? 5 times 2, but I can't get 2 out of that. 10 times 1, that won't work. So this is the factored form. It won't factor, so I get to use the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 2 plus or minus square root, let's see, 4 minus 40, negative 36. Now I understand why there was only 1 0 on the calculator. Because that's imaginary. They'll both divide by 2, so negative 1 plus or minus 3i. And x equals 3. So I found my 3 zeros. One of them I found with a little help from the calculator. The other I had to do by hand. Questions on that one? Use the calculator to get a good guess, right? In theory, we're guessing until we find one that works, but we're always going to find one that works because we're sort of cheating using our calculator. 17. Yuck. Find all the roots. How many roots is this thing going to have? 5. Boy, okay, well, it's going to be a fun one to put in the calculator. And maybe this goes without saying, but please be careful typing in the equation, right? Because if you type something in wrong, then you'll never get the right answer. Take the extra second to double check and make sure you've got all the signs right, exponents right. I know there's 5 roots. That doesn't guarantee I'm going to see 5 roots, but there are 5 roots somewhere. So graph. Let's see. 1, 2, 3, and that's all I got. Okay, 3 roots. If I find 3 roots and I start at x to the 5th, what will that get me down to if I synthetic divide 3 times? X squared, and that's what I need. So, okay, 3 roots. Finding them is, I guess I could check the table to see if there's any easy ones. I don't think there are, but it's worth a look. Nothing there, though. So back to the graph, which means none of them are integers. Second calc 0. Okay, this gets a little tricky because they're sort of off the, like when you move left and right, you go off the graph pretty quick. Actually, I can see that one, so I'm going to get that middle one first because it's right there. So left bound, right bound, guess. Oh, that's a nice one. Negative 1/3. Okay, here's a hint. If you find a nice one, go ahead and synthetic divide, because sometimes your reduced polynomial is, you can work with it. So rather than worry about finding the other two just yet, let's synthetic divide with negative 1/3 and see what happens. I mean, I know part of what's going to happen. I should get 0 at the end. Copy down the 9. Negative 3. Oh, that's nice, I guess. And you've got a calculator, so if you're struggling with 48 divided by 3, well, don't mess it up when you've got a calculator right there. Okay, so yippee, we proved that x equals negative 1/3 works, but we kind of knew that already. The point was, we went from x to the 5th down to x to the 4th. And maybe that's not usually enough, but that looks like we've solved problems like that before. So let's take a 3 out and see if we can factor what's left. Let's see. It would have to be 3x squared and x squared. Factors of 12. One of them's got to be multiplied by 3. You get to 16. Signs are different. We've got lots of options. 3 times 3, 3 times 4, that wouldn't do it. 3 times 6, though, that's 18. So minus 18 and plus 2. And now I can set each of those equal to 0. So I'm going to do the 6 first because that looks easier. X squared equals 6. So x equals plus or minus 6. What's going to happen with that other one? Fraction. What else is going to happen with the other one? That's part of the answer. Yeah, I'll have to fix the fraction thing. What else am I worried about here? What else is going on? It's imaginary. So plus or minus, that'd be an I. And then, yeah, I got to fix that. So that would be root 6 over 3. And then it's written at the top, but just to put them all together, negative 1/3. That's an ugly one. But I knew there was supposed to be 5 answers. Did I get 5 answers? Yep. And we sort of confirmed what we talked about yesterday. Square roots come in pairs. I's come in pairs. So that kind of matches up. We found one nice one, and we were able to algebra our way to the others. So the calculator is a nice cheat tool to get you as many nice ones as there are, and then you synthetic divide to find the rest. That leaves you at number 19 and number 13.